All right, so starting up with some coordinate geometry proofs. And one thing you guys got today was the coordinate geometry proof notes. So these notes kind of go through how to actually show a shape is like a parallelogram, rectangle, rhombus, square, and trapezoid. So when you're doing coordinate geometry proofs, okay, to show something's a parallelogram, there's 4 options. You've got to do one of them. All right. So one way to do it is to show the opposite sides are parallel. You're going to use the slope formula and make sure you show they're the same. Opposite sides are congruent. The distance formula, Pythagorean Theorem, that area, show that they're the same. The diagonals bisect each other means they have to have the same midpoint. So you're going to do the midpoint, show it's equal. And that one pair of sides is congruent and parallel. So pick 2 sides that are across from each other and do the distance and the slope for both and show that they're the same. All right. To do a rectangle, you can do all 4 right angles. That's an option. So you're going to get consecutive sides perpendicular. Do 4 slope formulas for the 4 sides. Show that they get negative reciprocals. There should be 2 pairs there, okay? You're going to do a parallelogram first. And then the first option is that you get 1 right angle. Or the second option is you do a parallelogram with diagonals congruent. So the right angle is going to be, this is the beauty of it, right? You do the slope formulas, okay? You show that all the sides are parallel because they're equal, and then you got 1 right angle and you're good to go. All right, if you're doing the diagonals congruent, you can do any one of these, okay? And then you're going to do the distance of the diagonals. You can show that they're equal. For a rhombus, which we'll get to tomorrow, along with rectangle as well, we're going to show that all 4 sides are equal. Okay, that's one way to do it with the distance formula. We can do a parallelogram, just like we did above here, and then show that 2 sides that are touching each other are equal. Okay, this is distance. Or we do a parallelogram with the diagonals congruent, perpendicular, and we do the negative reciprocals. A square is both a rectangle and a rhombus, so you're going to do one of each of these. A trapezoid is to show that you have 2 sides parallel, 2 sides not, so do the slopes. An isosceles trapezoid, you're going to do the trapezoid first, and then show that the sides that are not parallel are equal. Okay, that's going to be our options here. So let's go through the first one. So for the first one, the first property, we have a parallelogram. All right, so the first option was to show that the opposite sides are parallel. So opposite sides are parallel. And for this, we're going to use the slope formula. All right. The second one we can do is opposite sides. I should really write these words out. So we'll do that. Are congruent. That's going to be distance. All right, hold on real quick, guys. Making my lunch. Boiling water. So you're going to do the other ones. The opposite sides there are going to be congruent. All right, so you do 1 pair of sides congruent and parallel, and then we'll do that one down here. 1 pair of sides is congruent, parallel. This is both the distance and the slope. And the last one is that the diagonals bisect each other, which means they cross each other in the middle. So what we're checking for is to see whether they have the same midpoint. Okay? All right. The next one is a rectangle. So rectangle, we have 4, we say 90-degree angles, which really means that we have adjacent sides that are perpendicular. Here we're going to do the slope. Remember, we're looking for the opposite reciprocal here, okay? Second one is the parallelogram, see one of those above. And we are going to do 2 consecutive sides perpendicular, which is the slope formula. All right. Which essentially means we're getting 1 right angle, okay? And then the other option is get a parallelogram, and we're going to do the diagonals are congruent, and that's the distance formula. So essentially, anytime you do distance, you're showing that two sides are congruent. Okay? If we do slope, we're doing parallel or perpendicular, and if we're doing bisects, we're doing midpoint. So just keep that in mind as you're kind of working along here. Okay? Rhombus is that we're going to show that all sides are congruent, or at least consecutive. We want to say consecutive sides. That's the same option here. All right, and then this is the distance formula. The next one is to get a parallelogram, and then the other property you're going to show is that two consecutive, which means next to each other, sides are congruent. This is once again distance formula. The other option is to get a parallelogram first, and then show that the diagonals are perpendicular, and that's the slope formula. So square, remember you have to show it's a rectangle first, really, or it doesn't matter which one, and then a rhombus, or vice versa, rhombus first, then a rectangle. It doesn't necessarily matter. Trapezoid, we're going to show that two sides are parallel, and that two sides are not parallel. It's maybe a little overkill here, but that's what we're going to go with. And for this reason, the slope formula busts up the four slopes. Okay? And then isosceles trapezoid is going to be shows a trapezoid first, and then the two non-parallel sides are congruent. And this is going to be distance. Okay, so for our purposes here, the distance formula is we do capital D here, and usually we write the little side length down, this little subscript down here, okay? And it's parentheses x2, remember not an exponent, down below is a subscript, minus x1 squared plus y2 minus y1 squared. The midpoint formula, remember, is the average, so it's x2 plus x1 over 2, and then y2 plus y1 over 2. And then the slope formula, remember, is rise over run, so it's y2 minus y1 over x2 minus x1. It's delta y, which means change in y, over the change in x. Okay? Those are our three formulas that you're going to need to know. All right, so let's take a look at the first one. Shanti is surveying a new parking lot shaped like a parallelogram. She knows three of the vertices of parallelogram are 0, 0, which is down here in the first quadrant, 5, 2, 1, 2, 3, 4, 5, up 2, and 6, 5. That's 6, 1, 2, 3, 4, 5. So we want this to become the fifth point. So here's A, here's B, C, and I want D such that we get a parallelogram. Remember, one thing to keep in mind is that the sides are parallel. So if I want to get from C to D, I'm going to do the same move to get from B to A, which is down 2, left 5. So if I go down 2 and then left 1, 2, 3, 4, 5, that should be point D. And if you look, it's up 3 and over 1, up 3 and over 1. Those have the same slope, so we know we're good to go. Okay, so there's point D. So point D has coordinates of 1, 3. And now we're ready to go. So find the coordinates of point D, all right, and justify that it's a parallelogram. So we're doing two parallelogram problems. So let's just do, for this one, let's do slope. Okay, we'll do distance from down here. If you really, what I would advise you to do is pick one method that you like. Like, I like doing slope, it's easiest. So whenever I see parallelogram, I'm just going to bust out slope formulas. Okay, and I'm just going to show opposite sides of parallel, and I'm you know, we're in the business here. Okay, so we're going to do slope. The first side we're going to do it for is the side from A to B. Okay, and here you have a straight edge to draw that line. Now freehanding it looking like it sneezed in the middle. So we'll do M, and here's a little AB next to it so we're keeping track. I'm going to use the formula here, but you can also just use the graph, right? Draw the rise over run here and count it. Okay, so from A to B, we're using B as the second point. We know it's y2 minus y1 over x2 minus x1. That's the only time I'll write that on this problem here. So the slope of AB is going to be 2 minus 0 over 5 minus 0, which is equal to 2 over 5. We have the slope of BC, so same thing, C is the second point. So I go 5 minus 2 over 6 minus 5. Always put the minus down before you go look at that point, so you don't miss that it's a double negative. Okay, make sure you change those to positives. 5 minus 2 is 3. 6 minus 5 is 1, which is also just 3. You always want to simplify as well, so that at the end you can easily identify whether the slopes are parallel or not. Okay, the next one is CD. So we're using C first, and then D. So D is the second point, so we're actually going to start with D. So Y value is 3 minus Y value over here is 5 over X value 1 minus 6. Okay, so 3 minus 5 is negative 2, 1 minus 6 is negative 5, and that simplifies to 2/5. And so you can see that these two are equal. That means that they're going to be parallel. Okay, and then we do the slope of, and here we're going to go AD this time. So done BC, done CD, now we have to do AD. And so slope formula, right? Start with D, it's the second point, so it's 3 minus A is 0 over 1 minus 0, and I get 3 over 1, which is equal to 3. So what we want to do is we want to make a statement about our work. So just like in a normal proof, we show some work, we do statements, right? These are our statement. We want to do a little bit of work, show something about this, state something about this, do something. So here what we're going to say is we know that AB is parallel to CD, and we have BC and AD parallel, and we're just going to state Y, which is just that the slopes are equal. Okay, now we have to make a final summary statement down at the bottom. Okay, so what we're going to say is something about this shape. So what would we set to show? That this is a parallelogram. So shape ABCD is a parallelogram. That's our statement. Now we want to say something about it. How do you know? What property did we just show? Right? And we just say since the opposite sides are congruent. Or sorry, don't do that. Parallel. And we're good to go. That's it. Okay? So we're going to go on to the next one here, which is number 8. So we're going to start by graphing, and I would highly advise you to do this first. So graph it first so you can see the actual shape. Make sure you know that it's supposed to look like this shape, and then when you do your work, you can easily see it. Also, if you like doing like rise or vert on the graph, it makes it easier too. So negative 2, 2. Also, sometimes it does say graph and then do this. B is 6, 1, 2, 3, 4, 5, 6, and then 5. All right. C is 4, 1, 2, 3, 4, 4, 0. And then D is negative 4, negative 3. And there's our amazing parallelogram of doom. So we're going to show it's a parallelogram and not a rectangle. Okay. So one property of a rectangle that we want to key in on here is that the sides next to it, like there's right angles. And so what do you need to make a right angle? We need perpendicular lines. So what we want to show that is that there aren't perpendicular lines, right? There's no perpendicular lines here. And so by doing that, we need to use the slope formula. And by doing the slope formula, we can also use those to get, and it's a parallelogram. Okay? So let's do that. So here we can even use the graph. So remember we talked about doing this the other day. How do I get from D to A? I go up and then over. That's up 1, 2, 3, 4, 5 over 2. And so now I know the slope of AD is 5 over 2. To go from A to B, you can go up 3 and then right 1, 2, 3, 4, 5, 6, 7, 8. So the slope of AB is 3 over 8. From B to C, I go down and then left. So it's negative 1, 2, 3, 4, 5, and then negative 2. So the slope of BC would be negative 5 over negative 2, which is also equal to 5 over 2. And then the slope of DC, and we're going to go, let's go in the same order here. So we're going down and then left, and it's down 3, 1, 2, 3, 4, 5, 6, 7, 8. 8. So equals negative 3 over negative 8, which is also equal to 3 over 8. And so we can, that's the slope off a graph. We didn't have to put in the numbers. We still can, okay, but that's how you would kind of use the graph to show it. And here I'm showing my work, okay, by giving you the rise and the run from each point. So you can just use this as you guys go along, and you should be fine here, okay? So just keep working on this as you go along. As we do this again now, we want to make a statement about this. So we're going to say that AD is parallel to BC, and we're going to say AB is also parallel to DC. And all we have to say here is that the slopes are equal, and that'll be good enough. All right. We also want to indicate that AD is not perpendicular, okay, to AB, since they are not negative or opposite reciprocals. All right, this is super important. We got to make sure we say that, okay? All right, and now we can go ahead and do our statements. So we're going to say that A, B, C, D is a parallelogram. And we're going to say because the opposite sides are parallel, okay? And then we're going to say the same thing, except this time we're going to talk about it being a rectangle. Is not a rectangle. And easy enough, we can just say, because not all consecutive sides are perpendicular. You could even just say that not all angles are right angles, right, 90 degrees. And that would also be fine here, okay? So either one here, you're kind of good either way. All right, that's the second one. We're gonna do the third one here together, and then the fourth one here is for your homework. A little bit of work for that one. Not work, it's just a little harder. I want you to challenge time, right? Okay. All right, so first one, we got our 4 points. So A is 2, 3. B is 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, C is 8, 9, 1, 2, 3, 4, 9, 4. And then D is 2, 3, 4, 1, 2, 3. So we have A, B, C, and then D. Please make sure that the points actually look like the shape you're supposed to get. If this parallelogram and you got a point like, you know, if I switched it up into negative 3, 4, and was like, that's not right, okay? Go back and make sure you're doing it correct, okay? Make sure you do the first coordinate as your x, meaning left to right, then the second one is up and down. We're going to do prove a parallelogram, not a rhombus. Now, once again, an easy one for a rhombus here is that all the sides are supposed to be congruent. This is the distance formula, okay? So that's what we want to use here. And that will also help us get its parallelogram because the distance formula is supposed to show that all 4 sides are equal, all right, in a parallelogram. Sorry, the opposite sides are equal. So we'll be able to show that these 2 sides and these 2 sides have the same distance and therefore congruent. And then we can show that they're all different. They're all going to be different distances. They won't have the consecutive ones won't be the same. Okay, same thing. We're going to do the D, and then we're going to put our first one, which is AB. We're going to go to our points. So once again, B starting there, so it's the second x. So it's 7 minus, and then the first x is 2 squared, almost put it there, plus, and then we do the 10 minus 3 squared. So go to work. 7 minus 2 is 5 squared, plus, this is 7 squared. And really, just type in what's inside here. It's 25 plus 49. Spit out what you get, okay? Which should be 82. Is that right? 25 plus 49. No, it's definitely 4. Okay. How about 74? So close. All right. We're going to do the same one. Now, AB is supposed to be the same as CD, so let's do that one next. So the distance of CD, going once again from D, so that's 4 minus 9 squared plus negative 3 minus 4 squared. So here's our 5 squared plus negative 7 squared. Now I'm using parentheses around my numbers because if it is negative and I type it in, right, it's going to come out positive when I square it. So keep that in mind. And once again, that's 25 plus 49. We know that that's equal to 74. Okay, so one thing we can say here after this is that AB is congruent to CD, and we can just say the distances are equal. All right, now the next one we got is DC. We just did those two, so we want AD and BC here, okay? Now, another option here is to actually use the Pythagorean Theorem. So if I trace down and over, I'm going to get 1, 2, 3. This is 6 down, and then 1, 2 to the right. I can then just use Pythagorean Theorem here. So feel free to use this on your own. This is negative 6 squared plus 2 squared, and then this is going to be 36 plus 4. This is equal to 40, and then this is equal to the square root of 40. And we don't have to simplify. You can put it at the decimal if you want. Really, I'm just going to leave it as the square root of 40 for right now. Okay? We're going to do the same thing on the other side, right? We're going to go to over 2. 1, 2, 3, 4, 5, 6. And then down 6, so that's negative 6. And once again, when we do Pythagorean Theorem, we're going to notice that using the same numbers, you can actually just use the same Pythagorean Theorem, but we'll switch it up. So here's 4 plus 36, that's 40, and then the square root of 40 is equal to C. So now we can also add on to that we know that BC is congruent to AD. And likewise, we can also say that AB is not equal to, and what do we do? BC, and we can just say that the distances are not equal. Okay? So we need a summary statement again, right? So we're going to say ABCD is not a rhombus. Once again, we can just say not all sides congruent. Oops. Okay, you can also put down consecutive sides are not congruent. And then we also want to make sure we say that ABCD is a parallelogram. And we're just going to easily state that the opposite sides are congruent. We've already stated it here. Here's the property, and then we're good to go. That's it, guys. Homework tonight is going to be work on this one. So just go through, graph the 3 shapes, prove it's an isosceles triangle. I mean, you should graph it, be able to look at it, just show that the 2 distances are equal. That'll be isosceles. Graph point R, remember to use your slope to kind of figure out where R should go, and then show it the parallelogram. Okay? All right, guys. We'll see you on Friday. Good luck with the musical. Have fun.